after we've made all our measurements in the distillation lab, how do we figure out what the concentration of our distillate is? The distillate is the stuff you've captured or gathered up at the end of the distillation in that flask at the bottom. Well, we're going to use a graph, a calibration curve it's called, to figure that out. And this lesson is about how to get that done. So in our distillation of ethanol lab, we're going to be comparing the molar concentration of the solution against the density to create a calibration curve. Using that calibration curve, we're going to be able to figure out the molar concentration of our distillate, the ethanol we're distilling in the lab. We can start with the molar concentration of water in ethanol, and that would be traditionally the way that you would think about doing that, because water is in the smallest concentration in 95% ethanol. But to make the math work out a little bit easier, we're going to kind of back into that a bit. We're going to be using the molar concentration of ethanol in the solution, which is a little bit different than what you've been taught in class, but it'll make the math work out in the end a lot better. The graph will work out a lot better that way. So the one thing you need to know is in 95% ethanol, in chemistry labs we often shorthand ethanol as ETOH, capital O, capital H, capital E, small t. In 95% ethanol, if we were to calculate the molar concentration, we get a 16.37 molar ethanol solution. Okay. Now, every time we dilute a solution, let's just say we're diluting one that is 8 to 1 or 8 to 2. That'd be 8 parts of this 95% ethanol solution to 2 parts distilled or deionized water. Okay? If we were measuring that out, and you should very carefully measure your volumes, that would be, let's say, we're using 8.0 milliliters of our ethanol solution to 2.0 milliliters of distilled water. And we're going to use that then to determine what the concentration is of this diluted solution. So starting with 16.35 molar ETOH, or ethanol, say 16.35, and molar concentration is moles of the solute. This would be indicating that the solute is ethanol. Over liters of this ethanol solution, and we're going to multiply that by the amount of the ethanol solution we're using. Okay, so in this case we're using 8 milliliters. Well, you know that there are 1,000 milliliters in 1 liter, so 8 milliliters is converted into liters in this fashion, and we get 0.008 liters of our ethanol solution. Milliliters canceling here. And so I'm going to put up here 0.008 liters of ethanol solution is how much we are working with in this dilution. Put it over 1. And I'm going to get 0.13096. This is going to cancel out liters. And the ethanol solution, we're going to be left with moles. So this is moles of ethanol. And this particular solution here, we're going to round that off to, there should be another 0 here, because I have 2 significant digits here. This will be a 0 here and a 0 here. So we want 2 significant digits here. And so we round that off to 0.13 moles of ethanol. And so in this solution we have this many moles of ethanol. So to find the molar concentration of this new solution, we also have to take into account the amount of water that was added to increase the volume of the overall solution. 8 milliliters plus 2 milliliters of solution added together is going to give you 10 milliliters. So we're going to take that 0.13 moles of ethanol and put it over the total amount of solution. Well, this is 10 milliliters. Using this same system here to convert, we get 10 milliliters, which is 0.100 liters. 0.0100 liters of this newly diluted ethanol solution, and this is going to give us the molar concentration of the ethanol. Which I'm going to call 13 molar ethanol solution. Okay? Now, the density of the solution of our diluted ethanol solution is always determined by mass over volume. And most of the time when we're working with lab densities, we're using grams per milliliter. Okay? It was found that 10 milliliters of this solution had a mass of 7.90 grams. And so the density of our diluted 8:2 dilution, our diluted ethanol solution, had a density of 0.790 grams per milliliter. So we have 11 different solutions that you're supposed to find the molar concentration for and the density for, and then you're going to put those on a graph and compare density against molar concentration, with molar concentration being the independent variable. Then you're going to take your distillate and look at where it fits on the density side, the vertical axis or y-axis of the graph, and find where that hits the line comparing molar mass to density, and then go down to the x-axis to find the concentration of your distillate. And so to determine the concentration of your distillate, you're going to create a graph like this. And you're going to put a best fit curve in there. Choose linear as your best fit curve. Then click the try fit button to see what it's going to look like and see if it fits your data. And then as you can see, it looks pretty good, so we're going to put it in. I would move this box of information kind of out of the way so you can actually see the best fit line here. So what you want to do now is to be able to use this to compare the density of your distillate and look at how that compares to the molar concentration, and then that's how you're going to figure out the molar concentration of your distillate. To do that in a really easy way, you go to the top of this curve of Logger Pro and find the Analyze button. And using the Analyze button, then you can find Interpolate. Using that Interpolate function, then, and I'll move the box out of the way so I can kind of see what I'm doing. You can move the Interpolate vertical line up and down the best fit line and find where the density sort of matches. Look in that little box there and you can see how the values are changing. And let's say that we're trying to find a density of our distillate that's about, say, 8.5 or something, or 8.9, and you're going to look in there and move that vertical line back and forth until it matches as close as you can to a density of 8.9, and then it'll tell you what your concentration ought to be. Of course, you've got to have your concentration in the right number of significant digits, but that's how you're going to report the concentration of your distillate. And so to report your results, you're going to go to the folder that's been created for you in Google Docs, and find the document that's labeled Distillation of Ethanol and Determination of Molar Concentration. You have to complete the table here, and unlike previous tables, there's a little less on this table that's already done for you. You have to complete the table in the manner that you've been taught in this class. You have to have a table label at the top. Remember, table labels have numbers. They're numbered in a certain way. There's a period following that. You have to have a complete description of what's in the table, telling me what's in the table and why it's important. Column labels have to have information on what is in those columns, and if there are units of measurement for numbers in the columns, you have to have the units of measurement in the column labels. Remember, the data cells only include numbers. There are no units of measurement going into those data cells in the table. So once you've completed your table, and you can add more columns or more rows if you need to, you decide how you're going to do that. Once you've done that, you're ready to put in your graph. And so you're going to go back to that Logger Pro program, and you're going to find your graph and copy and paste it into this reporting document, just as you've done before. And once it's been pasted in there, then you've still got to do the figure label that goes at the bottom. So don't forget the figure labels. Explain what's in. They have a figure number too, but they're also explaining what's in that graph and why it's important, and also the analysis. And then lastly, you're going to write an analysis. In the analysis section, you're going to be able to explain, or should explain, what value you determined should be the concentration for your distillate, and explain why. That is to justify that claim. So you want to tell me how it is you got that concentration, why you think that's the appropriate concentration for your distillate.